So these are common on the exam because the theory is if you can find one specific term, you probably can write them all out. Where finding one term might find you a minute, writing out 6 or 7 terms might take you 3 or 4. So sometimes the exam will just say find the 10th term, find the 8th term, find the 2nd term, or sometimes it'll just say find the first 3 terms, ... So don't waste your time writing out all of the terms if the question doesn't ask, because it's just time you can use for something else. So example number 3 just says find the 9th term of x squared minus y to the 12th. And again, the point is not to write out every single term and then circle the 9th. There's got to be a faster way. So we're just going to look at the patterns that we looked at yesterday. If we look at the kth, which sounds ridiculous, the kth term of x plus y to the n is we know it has to have x to the something. We know it has to have y to the something. And we know it has a combination. Okay, so I'm just setting up those 3 pieces we talked about yesterday. What does the first value on the combination have to be? It has to be n in this case. It doesn't matter what term we're going to find. It's always going to be n. Now we just need to look at the relationship between the r value, which is the same as the second exponent, and the term number. So we know for term 1, the exponent at the back is 0. And for the second term, it is 1. And the third term, it is 2. And the 10th term, it would be 9. And the 20th term, it would be 19. So if we're looking for the k term, this would be k minus 1. So for the wordy person, it's 1 less than the term number. Okay, so term minus 1 or 1 less than the term number. Well, that means it's also the r value. So this has to be k minus 1, which is also 1 less than the term number. What's the relationship between the 2 exponents? Somebody looked at this. They add up to n. So we know whatever these 2 equal has to be n. So this is n minus k minus 1. Is this on your formula sheet, or do you need to know it? What I'm really saying is dig out your formula sheet and check. About 5 years ago, I kid you not, we were at this point in the course, and I said that, and a student said, "We have a formula sheet?" He didn't pass the course so much. Is it on there, or do you need to know it? It's on there. It's the very last one. And again, if you look now at the formula sheet, you've seen everything, and they're grouped by section. So all the first 2 units is on the left, and then it goes your logs. I think it starts with logs at the top. Kelsey, are logs at the top?
It's like the money stuff.
Oh, right. Okay, so the applications of logs, and then the new stuff. Okay, so it's on there. So example number 3. So x squared minus y to the 12th, and we just want the 9th term. I don't actually use the formula because I find the k's and the n's and stuff is confusing. I just use the same logic we did to create the formula. We know we have x squared to the something. We know we have minus y to the something. And we know we have a combination in the front. Okay, and all we need to fill in are the 2 subscripts for the combination and the 2 exponents. The first subscript from the combination, where does it come from? The exponent in the question, which is 12. That's never going to change. I mean, question to question is going to change, but it doesn't rely on the term number. It's always just whatever the exponent is in the question has to be 12. The r and the second exponent are exactly the same, and the only thing you need to remember is it's 1 less than the term number. So term number minus 1. So if we're looking for the 9th term, these 2 numbers have to be 8. Okay, and that comes from the term number minus 1. So that gives us just one blank remaining, which is the exponent on the first piece. And what's the relationship between the two exponents? They have to add up to give 12. So the second exponent is going to come from 12 minus 8, which is equal to 4. And then just like yesterday, we have 3 pieces. We need to figure out the combination. We need to figure out what that x squared to the 4 is and what our minus y to the 8 is. Once we figure those, multiply and squish them together, and we're done. 12C8 would be a calculator question. Sorry, 495 is the offer. X squared to the 4th. And a negative y to the 8. We really just need to know what's going to happen with the negatives. So a negative to the exponent of 8 is going to be positive, so we have a y to the 8. There's our 9th term. These are typically 3-mark exam questions. Okay, so again, they're typically asked one term instead of the whole expansion because they figure if you can get one term, you can get the whole thing. So why waste time doing 10 terms in this case when you can just give one? Number 4. 6th term, 2a plus 3g to the 8th. Okay, we know we have a combination in the front. We know we have 2a to the something. And we know we have 3g to the something. And now we just need to fill in the 4 spots. What's the first subscript on the combination and why? It is 8y. Same as the exponent. What's the r value on the combination and why? Why is it 5? Term minus 1, so always 1 less than the term. And again, that's because the first term starts with 0, and then the second term is 1, et cetera, et cetera. I like to go to the back then, because if this is 5, we know the last exponent is 5. And how do we find the exponent on the first piece? 8 minus 5, so what adds up to give you 8? 3. The total has to be 8. So 3 plus 5 is 8. Add up to be 8. Okay, find me 8C5. Offer 56. That would be calculator. 2a cubed. So remember, you have to cube the 2 and cube the a. Confirm. 3g to the 5. Confirm. Then what do we do at this point? This is usually where people get stuck. Yeah, just multiply the numbers. So I need to combine a 56 times an 8 times a 243. $108,864. And then what do I do with the variables? Smush them together. I have a to the 3, g to the 5. Before we go on to 5 and 6, which are the applications, we're going to squish in another example you're going to make up. So give me a first term for the binomial. 7, just 7. And minus 3x to the exponent 9. And which term would you like to find? I kind of heard those both at the same time, sorry. 7th term. Okay, go to. Okay, you tell me, so walk me through it. Okay, why is this a 9? Why is this a 6? Why is that a 3? Perfect. 9c6? 7 cubed? Negative 3x to the negative 3x to the 6th? 29, sorry. What are we multiplying? It should be a huge number. 9, 4, 8. Did I get that right? So you can kind of see it. 0, 0, 3. So 21,003,948. Who got it? Perfect. And negative times negative times negative times negative, negative. If there's even amounts of negatives, it's going to be positive. Okay, so 2 kinds of application questions that we've seen on exams. So they give you this lovely expansion with a fraction and 2 variables in it, and they want to know what term number has x to the cube, x cubed in it. Okay, so let's talk about it together. What would you do if this was an exam question? So take everything you know about binomial theorem, let's use it. Say that one more time. Okay, why does this one have to be bigger than the exponent on this one? Okay. So we know it's not near the end of the expansion, it's got to be near the beginning. Well, why don't we start expanding and see what happens? Okay, so how do we set up an expansion? This is what we did yesterday. Okay. Okay, we either have to do one term completely or do it all. It's up to you. Do you want to just keep going with the x's? We know it's probably not x to the 3 or lower. How do we know that? Because we're going to have to include this one here. So if you didn't know, you could keep going. We're going to use our logic. It's probably not less than this. Okay, how do we get the second piece for all these guys? 1 over x to the, okay, 1 over x to the, why do we not need the coefficient piece or the combination? Yes, more specific. Yeah, the question just wants to know which term number. If you want to put in the coefficients, you could put in the coefficients. There's nothing wrong with that, but they're not going to help us solve the problem. Okay, so let's simplify up this guy. So what's anything to the 0? Okay, so we're left with x to the 7. Okay, term 2, we're going to have x to the 6 times 1 over x. And this is just multiplying fractions, so imaginary 1 on the bottom, which is equal to okay, next term is going to be x to the 5 times and that's what they're looking for. So it's this term right here that's going to have our x to the 3. How do we answer the question? It's the third term. This is a 2-mark question. It was a justify. So you got 1 mark for saying the third term, 1 mark for justifying. This is enough to justify. Number 6. So a minus b squared to the 6, and they want to know what is the coefficient of the term containing the a cubed and the b to the 6. Okay, so where are we going to start? Imagine this is the exam question. I may not start with spaces with this one. I may use a little bit of logic before I went straight to the space. You could, but I would probably use some logic first. Okay, so we know there's an a to the something, and more specifically, the question has told us it has to be 3. We know we're going to have a negative b squared to the something. Why does it also have to be a 3? Because 3 plus 3 equals 6, and we can check if we were to simplify this term, we would have 6, which is what we want up here. We know we're going to have a combination. This r value has to be 3. Why? And the n value has to be 6. Okay, so we could have drawn out all the terms. We just used some logic instead. Okay? Now what? Okay. Offer of 20. Confirm. Why is the negative still there? Because it's an odd exponent. Now answer the question, because the question didn't ask for the term. What did it ask for? So negative 20 is the answer. Okay? If you left it the step above, it was a half mark off, because then you're not showing you understand what a coefficient is. Yeah. This guy here? Okay, why is this a 6? So right from the question. Other questions? Big round of applause, please. We're done. That was the last example. We're done the course. My work is done. It's all up to you guys now. We're going to work for a little bit, and then when we come back, period 3, we're going to do some exam questions, which will be the last time we're going to do exam questions. Kind of sad. And then you'll have some time to finish that off. You should have time to get it done, which means then you can work on starting to highlight those things off of your list or working on the exam review. We're done, Mrs. Hill, we're done. Oh, my work is done. Coffee break for me now.